Okay, next one. Sin x over 1 plus secant x. No choice but the quotient rule. So plain denominator, derivative of the numerator, minus plain numerator, derivative of the denominator, all over the plain denominator squared. Plain denominator, DEN denominator, derivative numerator, NUM numerator, plain numerator, derivative denominator, plain denominator squared. And you do not have to show that step. So now doing this, that's 1 plus secant x, derivative sine is cosine, then minus sine x, derivative of 1 is 0, derivative secant x is secant x tangent x, all over 1 plus secant x quantity squared. And there's my unsimplified derivative. But we want it simplified. And again, nothing here cancels initially. But yet, no matter how many times I say it, there are going to be 2 or 3 people out there that cancel the 1 plus secant x with 1 plus secant x quantity squared down there. You're going to lose lots of points. You do not cancel in a fraction unless you can cancel from all terms simultaneously. This term over here doesn't have a 1 plus secant x, so I'm not canceling it from anybody. Instead, I'm going to multiply out and see what happens. And so I get cosine x plus cosine x secant x, and then minus sine x secant x tangent x. All over 1 plus secant x quantity squared. Again, going to require basic trigonometry, and there's some basic trigonometry going on here, which is that secant is 1 over cosine. And we'll do that over here. Secant is 1 over cosine. And so on this first one, the cosine and the 1 over cosine cancel. And so I have cosine x plus 1. And over here, and we'll take it several steps here, sine times 1 over cosine is sine x over cosine x times the tangent x. And then there's more trigonometry going on here. Sine x over cosine x is tangent x. And so I have tangent x times tangent x over 1 plus secant squared x, or 1 plus secant x quantity squared, for a final answer of cosine x plus 1 minus tangent squared x over 1 plus secant x quantity squared. And there's the answer that I expect, because that really is just basic trigonometry. You are supposed to know the reciprocal identities. Secant x is 1 over cosine x. You're supposed to know and then you're supposed to know that sine over cosine is tangent x. And so there is the answer I truly am expecting. And then there are a few more games you could play with the tangent squared, but I wouldn't care about that. So there's that guy. Okay, next problem. Find the derivative. Now it's a product. Simplify first. Now this is going to be 3 times sine x times secant x plus cosine x times secant x. And then just like we did before, showing every detail, secant x is 1 over cosine x. And so this gives me 3 times sine x over cosine x plus 1 for 3 tangent x plus 1. And that is still the original. But it's in a much more calculus-friendly format. It's not a product anymore. I went from 3 trig functions down to 1. It is so much easier. And so then the derivative, again, that's just a coefficient. I do not need a product rule for coefficients. So 3 just hangs out. Derivative of tangent is secant squared x. Derivative of that 1 is 0. And the answer is 3 secant squared x. And even if you chose not to simplify it first and tried to, did it the really, really hard way, that's still the answer I'm expecting to see, 3 secant squared x. Same thing on the next one. Simplify first. Tangent is sine x over cosine x. And so I was thinking something else. Forget about that. There is not much good simplification here. So forget that I said that. I was thinking something else. But do think about possibly simplifying first, but there isn't a lot of good simplification here. I was thinking that said cotangent, and I was going to get some stuff to cancel, but there isn't good simplification here. So just a quotient rule. Plain denominator, derivative of the numerator, minus plain numerator, derivative of the denominator, all over the plain denominator squared. Plain denominator, derivative numerator, plain numerator, derivative denominator, plain denominator squared. You do not have to show that step. Now doing it. Plain denominator, so leave it alone. Derivative of 1, 0, derivative of tangent, secant squared x, then minus 1 plus tangent x, derivative of sine, cosine, all over sine squared x. So there's my derivative, unsimplified. And now let's simplify. So the first obvious thing I see, let's distribute that cosine. And so that's going to be minus cosine x, minus cosine tangent x. Nothing cancels. Those guys do not cancel. I can't cancel the sign because there's not a sign over here. And then distributing both the minus sign and the cosine, I get minus cosine x minus cosine tangent x. All over sine squared x. Then that's sine x, secant squared x, minus cosine x, minus cosine, and then tangent is sine over cosine. And so I get some good canceling there. Go on to a new piece of paper here. And so that's sine x, secant squared x, minus cosine x, minus sine x, all over sine squared x. And if you got to this point, I'd be happy, but there might be more stuff that you could do. So we'll just play around with it a little bit here. That's good enough. Playing around with it just a little bit more, again, to demonstrate the different things you might see. Let's rewrite it a little bit, just moving that sine x to the middle. And then from those first two, I could factor out a sine x. And so I'd have secant squared x minus 1 minus cosine x all over sine squared x. Still, nothing is canceling. Those sine x's just aren't going to cancel because there's not a sine over there. And then a little algebra recall, or a little trig recall. One of the Pythagorean identities that you are supposed to know, secant squared x, or 1 plus tangent squared of secant squared x, or taking the 1 to the other side, tangent squared x equals secant squared x minus 1. And notice we got a secant squared x minus 1. And so that could be sine x, tangent squared x, minus cosine x over sine squared x. And if this were a problem in my lab math, a problem from the computer, bet you anything, they have this answer. You don't have to get clear down to that answer. So I just really don't expect you to recognize, oh, here, I could factor out the sine, and then if I factor out the sine, I'll have secant squared x minus 1, and then I'll have a tangent squared. I don't expect you to catch right here that you could factor out the sine. But I want to make you aware of that these things can happen, and so this is probably the answer you'd end up with, but I'm good enough right back here that I do expect you to recognize, oh, something will happen with the cosine times the tangent. And that's where we'll end this video.